Every time you see players sprinting or dodging on the pitch, you're watching the power of locomotion, the simple but incredible act of moving your entire body from one spot to another. We usually take this for granted, but whether you are climbing the stairs at a crowded taxi park or carrying heavy bags through a market, every single step you take requires your body to support massive physical weight. This presents a major biological challenge. How does a heavy, soft-bodied organism hold itself upright against gravity while remaining fast and flexible enough to move around? Without a hidden internal framework holding us up, a human would be a soft pile of flesh on the ground, like a sack of pasho. Locomotion is only possible because of a brilliant partnership inside your body, a combination of rigid architecture and dynamic power. That architecture is your skeleton. It gives your body shape and holds up your weight. This framework is divided into two parts. First is the axial skeleton, your central axis, including your skull, backbone, and the protective cage of your ribs and sternum. The axial skeleton is built for protection. These hard bones act like a vault, shielding vital organs like your brain, heart, and lungs. Then there is the appendicular skeleton, the attachments. This includes your arms, legs, and the shoulder and hip bones connecting your limbs. This two-part system creates a central vault that protects your life, and mobile attachments designed to move that vault through the world. The center of that vault is your backbone. It's not one long piece, but a flexible chain of 33 individual bones called vertebrae. Not all vertebrae are the same. This small cervical vertebrae from the neck is built for flexibility, allowing your head to turn. Contrast that with the lower back's lumbar vertebrae. Its massive, solid base bears the heavy weight of your upper body pressing down. The shape and size of every bone in your body are perfectly matched to the specific job they have to do. Because bones are rigid and cannot bend, we rely on joints to move. A joint is simply the place where two or more bones meet. Your elbow and knee are hinge joints. Much like a door hinge, they allow the bones to swing back and forth in a single direction. To keep bones together, they're tied by ligaments, like tough sisal ropes connecting bone to bone. Muscles, however, attach using tendons. Like a bicycle brake wire, they transfer the muscle's pull to the bone. Movement requires this mechanical package: joints for pivoting, ligaments for stability, and tendons to transfer power. Generating that power follows one absolute rule: muscles can only pull. They can never push. Muscles work in pairs called antagonistic muscles. They take turns pulling. When you bend your arm, the front biceps contracts, pulling the forearm up, while the triceps relaxes. To straighten the arm, the back triceps contracts and pulls, while the biceps relaxes. Because a muscle is like a rope that can only pull, every physical action you take is a perfectly timed game of biological tug-of-war. If we look back at our football players through an X-ray, we can see all these mechanics firing at once. As the player winds up, those thick lumbar vertebrae stabilize the heavy weight of the torso. The knee hinge joint swings smoothly, held in place by tough ligaments, and the antagonistic muscles in the thigh pull sharply on their tendons to snap the leg forward with power. Your skeleton is a living, active framework that is constantly responding to every move you make. The next time you run, dig, or dance, remember the incredible machinery inside you that makes it all possible.